In 1923, Danish chemist Bronsted and British chemist Lowry both independently proposed a revolutionary theory called the proton theory of acid and bases. This theory is one of the most fundamental concepts of chemistry in general and is one of the most useful concepts in organic chemistry. The acid-base theory proposed that an acid is capable of losing a proton, in other words, an electronless hydrogen, in solution, whereas a base is the opposite, capable of picking up a proton from solution. If you mix an acid and a base together in solution, the base will pick up a proton from the acid and we form two different ions. These ions are called conjugate acids and conjugate bases, and will be the topic of the next video. In short, acid is a compound that loses proton, whereas a base is a compound that picks up protons. Bronsted acid and bases are not all the same. There are two metrics that we use to describe an acid or a base. The first one is the strength. A strong acid is one that dissociates its proton completely in solution, in most cases water. Hydrochloric acid, for example, is a strong acid, which dissociates into a proton and chloride anion in water. A strong base is similar, in which that it holds on to protons very tightly and doesn't let go. Most of the time, a strong base is an anion, such as an hydroxide ion or an alkoxide anion. Another prime example of a nitrogen strong base is LDA, or lithium diisopropyl amide. Note that the amide here is not the carbonyl containing amide, but instead is the anion version of an amine. Weak acids are instead less likely to completely lose their proton in solution. Carboxylic acids are usually weak acidic, meaning most of the carboxylic acid will not dissociate in solution. A weak base is similar, where it's happy to let go of the proton back into solution. Triethylamine is an example of a weak base. The second metric is concentration. Quite as expected, a high concentration of acid means the solution is more acidic. The measure of acidity is the pH, or minus log of the proton concentration in solution. A potent acid is one that is highly concentrated and the acid is strong. It is possible to have a very concentrated weak acid and a very dilute strong acid. Many people draw an equal sign between the strength and the concentration of acids and bases, which is incorrect. This concludes the video. I hope it had been useful, and I hope to see you again next time.